today we're going to take we're moving on from expressions and we're moving on to equations. Okay, but before we get to equations, just like remember when we started the school year that I showed you how we use math on a daily basis by introducing expressions using the additive inverse property. Remember that, the zero pairs? Well, the other day I was at Cardenas and I recorded myself so that you guys can see how equations came about, but you're going to see what I saw. Hopefully you see it. Here you go.
All right, guys. This is Mr. Q here. Hi, I'm here at Cardenas doing some shopping. Check it out. And basically what I'm going to do, I'm going to buy some pears. They're on sale right now for 79 cents a pound. So basically how this works, I put some pears in a bag like so, and then I weigh them, and to weigh them I need to put them on the scale. So check it out. Here goes the scale. This is the scale. Now this works right now is showing 3 pounds right there. So that means that 3 times 79, well 3 times 80, that's about $2.40. And pretty much that's how scales work. It's to weigh stuff and to give you an accurate measure, but we say that it's an estimate. But this is just to show you how math is used on a daily basis. And equations, now that we're going to be introducing equations after expressions, are based on scales. And scales, not this type. This is already like a more modern type of scale, but there's an actual scale that looks like a actual balanced equation, and I'll show you that later on when we introduce it. All right? Just wanted to show you how it's used on a daily basis. So let me do some shopping and enjoy the video, and I'll check you guys out once we get started. All right? All right. See you in a bit. Bye.
So basically, yeah, I know, right? People were looking at me weird. That's why I kept looking. Did you guys see that I kept looking up? I was recording myself, but people were walking by there looking at me like, okay. Anyways, so basically that's how scales are used in a store. Who's seen the ones at Walmart? You hardly see them, but they're the flat ones that as they're checking out, it's like a flat surface and they can weigh stuff and it's digital already. But look at the one prior to that one. It looks something like this. Yeah, it's got 2 pans, one on each side, and how this works is like this. Watch. Let me do some math magic here. Let's see. Let's say I got one of these weights that came with the actual scale, and each one of these weights measured a specific amount. So let's say this one was 1 pound. So if I placed it over here, this side is going to come lower because it's not going to be balanced anymore. It's going to be heavier on the right side. Is that correct? But if I needed to make it weigh the same, that means I need to get another one and place it over here, and it will be balanced again. Is that correct? Now, before this one, there were these scales. Who's seen those before? You've seen them. Some use them. You see those at places that sell gold and jewelry. They have these. Or you've seen them in some coins. You've seen them on the dollar bills. I think they have those, or some type of bill. Well, check this out. Equations come from this idea of a scale. Now, I know in the past you probably solve equations. They just told you need to do this, and you get an answer. Remember? But this year, I want you to understand what it means or where it comes from. So check this out. So if I was to add weight to this side, let's say I added 8 pounds. And let's say I'm at the store, and I tell the whomever, can I get 8 pounds of frijoles? So they'll add a little bag on this side, and they'll start pouring frijoles in here, right? And they start adding the frijoles. They keep building up until what? When will it get balanced? When it reaches what? 8 pounds, right? So once it reaches 8 pounds, this is going to balance out. Well, guess what? Equations came from that idea. Watch. So let me show you how the scale looked like if it had a little design here. There's the base right here, okay? And let's say that rested on top of a table. Here it goes. Here's a table. There it is. So there's my table. There's a scale. Is it kind of crooked or a little bit? There it is. So watch. So there's my table, and this is the original bar right here. So I'm walking away. Check this out. You're walking away from the stand, and you're already like close to from here to the gym, and you can barely tell the bar and the table. You guys see the bar? Can you imagine the bar and the table from far away? Here's the scale bar, and look what it makes from far away. All you see from far away is that. And what is this? An equal sign. That's where we get the idea of equations. So when it's balanced, it's an equal sign. Now check this out. Let's see what happens when it's not balanced. Watch. Let's clear this. I'm going to add weight to this side. That's 11. So on this side I have 11 pounds. What's on this side? No. What is on this side right now? Nothing. So it's 0. So let's see. What was the original bar? It was about right here. And where is it now? You guys see it? And that becomes a what? Inequality. Do you guys see that? So that's where we get the idea of equations and inequalities. And you're like, oh my goodness, I've been living a lie. My teacher told me the alligator and the Pac-Man. No. So equations come from scales. As long as we keep it balanced, it's an equation. If it's not balanced, it's a what? Inequality. Are we there? So today we're going to focus on equations. So with that said, our objective for today, I can solve and graph one variable equation. Read together. 1, 2, 3. I can solve and graph one variable equation. Get your Cornell note in front of you, please. All right, here we go. So on your Cornell notes, at the bottom left, it should say, I can solve and graph one variable equations. Write your name, date, period on the top right corner. And I give you a Freyer model. Is that correct? Now, look at this question. We'll address that in a little bit. It says, what's the difference between an expression and a one-variable equation? Bless you. What's the difference between an expression and a one-variable equation? Don't write it down. Don't write it down. Just pay attention, and we'll come back to that. What's the difference between an expression and a one-variable equation? Okay? So, give me a second. All right, here we go. So, Freyer model. I gave you guys a definition, and I gave you guys examples. Is that correct? It says, one-variable equations are mathematical statements where two expressions are equal to each other and contain one unknown variable. And I gave you all these examples. Now, that's a mouthful for a definition. So in order to shorten it and to make it a little bit clearer, if you have your colored pens in red, I'm going to ask you to underline where it says two expressions equal to each other. Two expressions equal to each other. Two expressions equal to each other. Is that a little bit shorter? Yeah, right? Now check this out. Let's see if you agree and if it's true. Last week, in the prior week, we covered expressions, and we covered two types of expressions, numerical and algebraic. Remember when we did the concert thing? Yes? So let's see. Look at x plus 2. This is an algebraic because it has a variable. Look at 25. That's a numeric. Are they equal to each other? Yes. Look at y minus 8. That's an algebraic expression. Look at 12. Is that a numerical? Yes. Are they equal to one another? Yes. Give me a second. All right. So let's see. Look at this one. Is this a algebraic expression? Yeah, it's got numbers, operations, and a variable. Is this a numeric? Yes. Are they equal to one another? Yes. Look at all the rest of them. They're pretty much two expressions equal to each other. Is that correct? Now let's look at the last part of the definition. One unknown variable. Let's see. Look at this one. Does it have one unknown variable? Yes. This one? Yes, 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 and yes. So far, so good? So according to the definition, one variable equations have two expressions equal to each other. We saw that. And one unknown variable. We saw that. Are we clear on that? All right. So with that said, non-examples. Let me show you some non-examples. Copy these. we have x plus 5 minus 25, 12 greater than x minus 8, x squared plus 5 equals 30, and 4x plus 6 equals negative 2y. Copy those. As you're copying those, start thinking, why are these not one variable equations according to the examples I have? Copy that, please. All right, talk it over with your neighbor. See why these are non-examples. Each of these is a different situation. See why those are not examples of one variable equations. Go. Okay, let's see. Let me zoom in for a little bit. All right, let's focus on this one right now. Okay, so volunteer for this one. Yes, Victor. Why is this not a one variable equation? Because it's an expression. Did everybody hear that? If it's an expression, it's missing the what? The equal sign. It doesn't have an equal sign or an equality sign, so this is an expression. So far, so good? Pass it to someone, Victor, this one. Why is this not a one variable equation? Has the alligator thingy called the inequality? So this is an inequality. This is an inequality. Are we looking at inequalities right now? No, we're looking at one variable equations. Okay, pass it to someone, this one. Callista, why is this a non-example? Now let me show you the ones over here. Look at all the variables. Because this one has an exponent. An exponent what? Greater than 1. An exponent greater than 1, okay, on the variable. All right. Pass it to someone, this last non-example. Joseph. This one has 2 variables. Does everybody see all that? All right, let me zoom out. So, these are non-examples, these are examples. So what is the most important thing to remember about the one variable equations? Well, number 1, they need to have equal signs. Number 2, one unknown variable. And number 3, no exponents greater than 1 on the variable. Copy that. All right. So we got our concept, all right? So let's look at the steps that I gave you guys. I gave you guys 4 steps. Number 1, solve each side of the equation. Start with grouping symbols and combining like terms. Simplify each side. Step 2, isolate the variable by using inverse operations. Step 3, plot your solution on the real number line. And step 4, check your solution by substitution and the value of the variable into the original equation. Now check this out. Simplify each side of the equation. That means we need to make each expression shorter. Step 2, isolate. The word isolate means to leave it alone. Leave it alone, which means leave it by itself. And using inverse operations, from there, plot and check. So check this out. Let's circle the key words here. Keywords for the steps. Keyword for the first step is simplify. Circle that. Step 2, isolate. Circle that. Step 3, plot. Circle that. Step 4, check. Circle that. 4 basic steps. Simplify, isolate, plot, check. 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 Tell your neighbor the steps without reading. Bam. That was good. All right, so now check this out. So we got our steps. Now, before we continue, let me show you really quick what we're going to be looking at. Look up to the screen, please. Pens down, look up, please. Writing utensils down. Look up to the screen. Check this out. Now, I want to clarify this from right now, just to make sure everybody understands what we're looking at. Let me zoom in. So here we have 4 different equations. Let me show you the first one. The first one says x plus 2 equals 25. The operation here on this side is what? Addition. What is the opposite of addition? Subtraction. This one we have y minus 8. So what is the operation? Subtraction. So what is the opposite or the inverse? Addition. Here we have 2 times a equals 14. There's a multiplication sign here, an invisible one. So what is the inverse of multiplication? Division. And then look at the last one. Here we have m divided by 4. So the operation here is division. So what is the opposite? Multiplication. So therefore, those are what we're going to use to simplify the each side and to isolate the variable. So with that said, 2 properties that we're starting with today, the addition property of equality and subtraction property of equality. What does that mean? Whenever we add something to each side of the equation, we're calling it addition property of equality. Whenever we subtract something to each side of the equation, we call it what? Subtraction property of equality. Does that make sense? So what is it called when we add something to each side? Addition property of equality. What is it called when we subtract to each side? Subtraction property of equality. Are we there? All right, so with that said, copy this example down, please, underneath the steps. Example 1 says, solve the equation, check your answer. Solve the equation, check your answer. Copy that. All right. Pens down. Let me go over this one. Here it goes. I'm going to zoom in. So, check this out. To get started, I'm going to follow the steps that I gave you. Step 1 is to simplify each side. But before I do that, I'm going to draw a line down the equal sign to remind me that this is a scale. I need to keep it what? Balanced to both sides. Are we there? So, can I simplify this expression here? No. How about here? No. Simplify, isolate. What is the second step? Isolate. What does that mean? To leave the variable by itself, which means we're going to use inverse operations. What is the operation here? Subtraction. So what is the inverse? Addition. And what is that number? 3. And whatever we do to one side, we do to the other side. Why do we do this? Tell your neighbor, why do we do the same thing to each side? Where does this come from? Doing the same thing to each side. All right, good. Because it comes from a what? A scale. It needs to keep balance. Now it's no longer your teacher saying, because I said so. No. It's a scale. It needs to keep balance. Whatever we do to one side, we do to the other. So here, -3 and 3 is a 0 pair. We're left with y equals 7. Copy that, please. Okay, according to our set, simplify. We couldn't simplify. Step 2, isolate. Did we isolate the variable? Leave it by itself. Yes. What is step 3? Simplify, isolate, plot. That means we're going to draw a number line. Draw your number line. Underneath here. There it is. Nice and straight like mine. Whoa. There it is. We go 0, 1, 2, 3, 4, 5, 6, 7, and we plot our point. Focus, please. And what is our last step? Everyone, check. do that underneath here. We write our original equation, y minus 3 equals 4. But now, instead of y, what are we going to substitute in there? 7. So this is 7 minus 3 equals 4. And this is 4 equals 4, which is true. Fairly simple? Okay. Now, this is all good and dandy, right? However, on your paper, draw a line down over here, and you have a lot of space on the right side. Is that correct? Okay. What we're going to do next, I want you to do it on the right side. So today, a different way that I'm going to introduce this is using cups and tiles. So get your tiles out from the baggie with those cups. Get them out. So, focus, focus, focus. So now that you have them out, I want us to start setting it up using this equation, the one we just did, but using cups and tiles. The variable will be represented by the cup, and the rest of the stuff by the tiles. Are we there? So check this out. Focus, please. So what are we starting with? Y, which is a what? A cup. So put that in front of you. There it is. There's a cup. All right. What is next? Negative 3. So you're going to take 3 negatives. 1, 2, 3. There they are. All right. Now check this out. For the equal sign, I'm going to draw a line down like so that it reminds me of the balanced scale, right? So now check this out. What's on the other side of the equal sign? 4 positive. So show me that with your tiles. 1, 2, 3, 4. There it is. Are we there so far? Okay. So now, looking at these tiles, how do we cancel these 3 negatives? Tell your neighbor, please. How would we cancel those? I heard 0 pairs. Who said 0 pairs? Right? We can do 0 pairs. So how can we do 0 pairs for this one? We need a what? How many? 3 positives. So we're going to put 3 positives underneath. 1, 2, 3 positives. But since this is a balanced scale, whatever we do to one side, we do to the other side. So we're going to add 3 positives to the other side. 1, 2, 3. There it is. Now what happens to these? Look up. What happens to these? They cancel, right? So take these out of the way because they become a 0 pair. And what do we have left? A cup and 7 positives. Did we get the same answer? Yeah, pretty much, right? So now, what I want us to do, though, let me minimize this. Check this out. Check this out. What I want us to do is actually draw a picture that represents this here. Now that we know how to use these, let me turn this off. Let's draw the picture. Instead of using the tiles, we're going to draw the picture right underneath this. So what can we draw for the Y? A cup. But what figure can we draw for the cup? A circle. So therefore, a circle. And then, everyone, 3 negatives, 1, 2, 3. And then, a line down. And then, 1, 2, 3, 4. Is everybody following? All right. So to cancel these, you said we make them 0 pairs. So what do we need to do? 3 positives, 1, 2, 3, and whatever we do to one side, we do to the other. And now let's indicate this here. We identify the 0 pairs. They cancel. We bring down the cup. And what do we have on this side? 1, 2, 3, 4, 5, 6, 7. And that's how we use cups and tiles. How are we doing? All right? Okay, let's do another one. Copy this next one, please. Example 2. Example 2. Solve the equation, check your answer. We got 2 plus t equals 8. 2 plus t equals 8. Let's do this one together. Here we go. So what is the first thing we do? We draw our line down to keep it balanced. There it is. Nice and straight like mine. All right. So what is our operation next to the t? So what is the inverse? So we're going to subtract, and what is that number next to the t? 2. So we're going to subtract 2, and whatever we do to one side, we do to the other. So 2 minus 2 is a 0 pair, so we're left with t equals, everyone, 6. Yes? Piece of cake? So simplify, isolate, what's our next step? Close. Plot. Let's plot our answer. We got 0, 1, 2, 3, 4, 5, 6. I'm going to plot my point right there with blue. And our last step is to check. So let's see. We got 2 plus t equals 8. But instead of t, we're going to use 6. 2 plus 6 equals 8. And this is 8 equals 8. How are we doing? Good, Mr. Q. All right, good. Now let's draw the picture. Draw a picture. Let's say if we were to use tiles, what do we start with, everyone? 2 what? Positives, 1, 2, and then a cup, which is circle, bar, and then we got 1, 2, 3, 4, 5, 6, 7, 8. Okay? So tell your neighbor what to do from here. What is the next step? I heard again 0 pairs, yes? So how many do we add? 2 negatives, right? 1, 2, and whatever we do to one side, we do to the other. And from there, we're going to circle our 0 pair, cancel that. How about the other side? Do we have a 0 pair? Yes, right there, cancel that. So we're left with cup and 1, 2, 3, 4, 5, 6. How we doing? Good? All right, I'm going to send you one on your iPad, so you can do that one on there, and then send me your response as soon as you can. Here it goes. This next one, do on your iPad. Hold on, copy that, please. Let's see. Copy this one, please. Example 4. Solve the equation and check your answer. This one on your paper, if it doesn't fit in the front and the back. 4.2 equals t plus 1.8. 4.2 equals t plus 1.8. Solve that one, please. Simplify, isolate, plot, and check. On this one, you don't have to draw your picture. Go. All right. Let's see what we got. Line down the equal sign. What is the operation next to the t? Plus, what is the inverse? Subtract 1.8. Subtract 1.8. This is a 0 pair. We bring down the t equals. Oh, it's frozen, sorry. Let's see. Can we take away from 2? No, we borrow from here. This is 3. This is 12. That is 4. And this is 2. So therefore, 2.4 equals t. Hands if you got that. Okay. And then the graph should look something like this. We got 1, 2, 3. 2.4 is about right there. 2.4. And then we check. 4.2 equals t plus 1.8. 4.2 equals 2.4 plus 1.8. And 4.2 equals 4.2. All right? So, finally, before we leave, let's see. Question. On your screens it says, take a quick poll. How comfortable are you with one variable equations? And our home play for tonight is a play sheet, and it's in the back, so grab it on your way out. Have a good one, everyone. There's tutoring today. If I don't see you guys tomorrow. Bye. Bye.